Everyone, thank you so much for joining this session. We're going to be talking about big tables and big problems and scaling beyond SQL. This is very hard, by the way, because it's so large. So I'm going to be looking up at myself a lot, just an FYI. And basically what we're going to be talking about is when to switch over, when to consider a NoSQL solution on top of your RDBMS. So let's dive right into it. So a little bit about me. Who am I and why should you? My name is Tristan Chiappisi. I work as a principal data architect at Cetera Financial Group. I've been there for about 4 to 5 years now, 4 or 5, one of those two. And I've been a data nerd for about 20 years. My shtick is I work on application development teams as the data person. As a data person. So basically, I don't write a lot of code, but I do a lot of data stuff, making sure that the data is right and working directly with the application developers. I know how to write code, but I try to bias myself towards the data side of things. So it's a really nice role being a principal data architect at this company. I have a big family. I've got 5 kids, as you can see here, and a beautiful wife. So, and that keeps me very busy. The things I like to do is travel, ski, and play board games. I put this picture up there because it's the coolest thing for all the board game nerds out there. Who knows Carcassonne? I played Carcassonne in Carcassonne. Yeah, that was the reason we took the trip to France. We tried to like theme the trips, and we did that just for that trip. So that was my favorite thing in the world. So that was just at Niagara Falls, and that's just a picture of board games that we play all the time. So I hope that Star Trek comes up with a board game room like Code Bash. So, all right. So we'll dive right into it. What are we going to talk about? The first thing is we're going to talk about the problem. What is the problem? Like, why are we talking about this stuff today, right? When to move beyond SQL, choosing the right NoSQL tool, architectural patterns, and practical strategies. So they're all kind of mixed in. So it's not a sequential thing. So it's all kind of mixed in. But this is kind of hopefully what we'll walk out of this with. Before we start, though, when I say SQL, I really mean RDBMS. So in the industry, everybody says SQL. It's actually, SQL is considered Microsoft SQL Server in a lot of ways. I mean RDBMS, which is a relational database management system, Postgres, MySQL, Microsoft SQL Server, Oracle, all that stuff. So when I'm referring to that, that's why. There are more NoSQL tools other than DynamoDB and Elasticsearch, but I'm just going to focus on those today. NoSQL was originally stood for non-SQL, but nowadays it's really considered not only SQL. So when we say NoSQL, it typically means, at least in my opinion, it's not only SQL. So I have RDBMS and I have something else to manage my data. I put this in there as a quiz item, guys. Rule of thumb: if you have over a million tables, a million rows in a table, you might want to consider something else. In my current role, I primarily use Postgres, and I'll probably use a lot of the terminology for that. So just an FYI. So a like versus an I like in Oracle is kind of weird. So because this is an offline presentation, I typically do live coding things, but because this is offline, I wanted to come up with a use case. So actually, I skipped ahead, sorry. So the problem is SQL works great until it doesn't. And what I mean by that is SQL really struggles at scale. So at large scales, SQL doesn't perform the best in a lot of ways. Who here has had a table with over 5 billion records? This guy. All of these people have. And how much has it sucked, right? And it's impossible to work on, and it's fragile. It makes your OLTP system really tough to restore, back up, any of that kind of stuff. You get complaints from your DBAs all the time. So some people might say, well, I'll just use partition, and that's going to fix it. Sometimes it does, but a complex partitioning strategy can cause more issues than it's worth. So keep that in mind. So SQL wasn't designed for this specifically. It's meant for ACID-based transactions. Performance really degrades with sheer size, not just bad queries. We all deal with bad queries. We all write them too. I write them. Everybody's seen the big queries like this big, and they have subqueries and everything like that. We all deal with that, but those things get really bad when the database grows. Capacity rises exponentially with joins and indexes. So you add another join to a table that has 1 billion records, the query is going to probably act pretty bad. So what worked at 1 gig typically collapses at a terabyte or more, or half a terabyte. So when we're working a SQL server or a SQL database, I'm constantly figuring out how much data is this table going to be, or how much in the next 5 years, 10 years is this table going to be, and then making solutions based off of that instead of just building a table and saying next developer can handle it. That's really my role at Cetera. So this is where I was going with before. Because it's an offline demo, we don't have good internet here, I decided to come up with use cases. I have 2 use cases, and as you can see here, I have Product Trender 2000. This is a application very similar to something that sounds like camel, camel, camel. It's just a fictitious application. Whoops, I full screen myself. There we go. It's a fictitious application to prove 2 points. 1, type ahead search. This is really hard to do in SQL, right? In RDBMS, for type ahead search, it's really hard. It's really taxing on the system. The other thing is price trending. This seems really easy to do. This is 5 years worth of price trends, 1 per each day. But there's a problem. If we went into this, most of us, if not all of us, would design a table structure like this, just building the application. So I have a product table. I got a product ID, a name, description, category, current price. Got some data there. You know, I got my wireless headphones. And then I have a product price history, so I would have a row for each of the price history dates, right? You could do some other fancy structures, like you could have 1 row per week and then have multiple things in there, a price for each day, basically go wide with it. You still got a lot of records. In this case, this is what most of us will do if we were given this problem to build. There's a problem with it. Once we do some back-of-the-napkin math, and this is what I try to do every single time we create a table or I'm working with developers. I work with 10 different development teams, and I review a lot of the tables, my peer or myself review a lot of the tables that are going in, and we have a lot of scrutiny around them. And the first thing we do is back of the napkin math. So let's talk about this, right? The number of dimensions times the number of days for one product, for our wireless headphones, in 5 years is going to be 1,825 records per day, or per item. Let's say that we become popular. We're at 1 million products. That's close to 2 billion records in one table. That's a lot. And that's just for 5 years. Then what happens is your product owner comes through. Anybody heard of a product owner? Product owner comes through and says, whoops, I'm going to go back. Product owner comes through and says, you know what? This price trend thing is cool, but I want it by vendor. And you have 50 different vendors. So in that case, you're at 100 billion records. And then what do? You stick it in one big table? You could. You stick it in a bunch of different tables. This is what we typically do. We would say, well, what if we have a table per vendor? Or DBAs come around and say, we got this cool partitioning thing we can do. You're still at a loss because you have 100 billion records in your OLTP system that needs to be small and nimble. So this is a big problem, and this is what most of us run into. So one of the ways to prevent this is to tell yourself, if you come out of this with one thing, when you're creating a table, just ask yourself, what's the potential of this thing growing, right? And I always do the rule of thumb of 4 things: 1, 3, 5, 10. How many records is this table going to have in 10 years? And most of the time, it's pretty big. So then we start considering different things. I'm sorry, most of the time, it's not that big. Most of the time, it's like, oh, it's 1 million records. It doesn't matter. But in some cases, and I've been burned on this myself many times, where I didn't predict right, and it has way more records than I expected, and we had to come out of a solution. Then we have to spend a ton of time and money to redesign the solution and now do something else. So if you come out of this with one thing, it's back of the napkin math on the table growth and do your projections. On every single table you build. It's really important. I keep going backwards. So is NoSQL the solution? It might be, right? It really depends. So what is NoSQL? Essentially, it's a big hash map in space. And you guys can read this if you want. I won't read it verbosely, but basically it's a non-relational database model. It has high reads and high writes because it's basically just a big hash map. in space. And it has a lot of benefits, but it has a lot of the downsides because of the way the data is designed. You can't really do a lot of joins. The schema is flexible, which is great and bad at the same time. And but it's really ideal for handling large volumes of data. If you care about it, you can do unstructured data too. I'm not a big fan of that because I'm a data person, so I don't really like unstructured data as much, but semi-structured is good. And NoSQL is really good for user session logs, user sessions, logs, or product price histories, things like that. Think about the NASDAQ. They have to track and keep history of every single price about every minute for every single stock ever, every single ticker. So it's quite a bit. So I'm sure they don't use a SQL Server database for that. At least I hope not. Now, I want to say one thing before I keep going. There are some of the new emerging database technologies that do both of this. There's Cosmos DB, I think, by Microsoft, and they do some fun things where they do, they have one big database that does relational plus some of this stuff, and it's all one big thing. So I'm not going to talk about that too much. There are tools for that, but I'm not too familiar. I just know that probably the far majority of people in this room have some kind of a Postgres, Microsoft SQL, MariaDB, MySQL, something like that. And they may be struggling with this. So what NoSQL tool do you choose? This depends on your use case. So we're going to be focusing primarily on Amazon DynamoDB versus Elasticsearch. So DynamoDB is really good for fast lookup and time series data and ledger data. And what I mean by ledger data is that it doesn't change. It's in the past, right? It's just a receipt history of whatever happened in the past. So price is a really good example, and that hopefully shouldn't change. I would hope not. Sometimes it does. And I will note that sometimes you realize, oh, the prices were actually bad on those days, and you have to go back and update it. That happens, but majority of the ledger data, it just stays there and it's static. Elasticsearch excels at full text search, filtering, type ahead experiences. So when we're in Amazon or on Google, we start typing and it starts popping up the next thing. That's extremely taxing on a database if we don't know that, right? Because you're doing select where product like, where like, and you continue to send that query down to the server, or you have to cache a bunch of results, and it's really, really expensive. So tools like Elasticsearch are really good for that. Let's see here. I wanted to go over, I won't list all these things. Yeah, so the speed part I wanted to talk about. So ultra-fast reads and writes. So DynamoDB is really, really good at fast reads and fast writes because it's the way the partitioning is done. It's based on a unique partitioning key and a sort key. And you can just rip things in there all day long and read them all day long also. And it's extremely fast. Elasticsearch, on the other hand, is really good at reads, but it's pretty slow at writes. So when you load data in, it's not as fast as you would want it to be. So there is a major difference there. So, and then the scaling, fully managed serverless. Elastic, there's a lot of setup to it. If you use DynamoDB, has anybody used DynamoDB here? It's pretty easy to set up. I mean, it's not that much to it. You set it up, you define your partition key and your sort object, and you say if it's going to be multi-region, all that fun stuff. When it comes to Elastic, there's a lot of stuff. It's much more database-y, I would say, or setup-like. So you have to spend a lot more time on Elastic setup. DynamoDB, though, I'm a big fan of because it's so simple. Before I go on, does anybody have any questions? So I wanted to go through two use cases here. So DynamoDB price charting, which is this area here. So how would we do this? So in our world, we have in our previous schema, we had a database, we had a product table, and then we had a product history table, a product price history table that had all the data in there and had one record per each product for each day what the price was. So I can continue to tell what's going on here. How would we design the database schema? It would probably be pretty similar. you would probably still have a price history table. If you look at the left bottom corner, you would have, that schema would still exist. However, you would migrate the data over on a daily basis, and I'll show that in the next slide. So these are the two different scenarios with and without DynamoDB you could do. This is just one pattern, by the way. There's a trillion of them. So without DynamoDB, your web app used to query everything from SQL Server. So if you had to get 5-year price history, you're scanning a table with billions of records. It's going to be slow, or if there's maintenance on the table or whatever, it's going to have a lot of issues over time. And I wanted to point out, most of these things don't have a problem until later on. So if you design this thing 3 years later, it starts to choke. And then 4 years, and then at that point, you can throw some money at it, right? We've all been in the scenario where we said, you know what, I'll just ask management to throw $10,000 more, get on a new EC2 server and all that stuff, and everything's great. But the 4th year comes around, and that stops working. And then you are in a situation where you're in a panic and you need to do that. Been there before, and it's not fun to do. So to be able to predict it and solution outside of that is much better. Because what happens is, if you up your server capacity, it's a very expensive cost to do. And if you design it right, it's going to be much cheaper in the long run. So with DynamoDB, we're now offloading the time series data to DynamoDB here. Each system does what it's best at. So SQL Server for metadata. So product data, customer data, things like that. Any ledger data, any receipt history, things like that are prime examples for things we may want to put into a time series database, a DynamoDB, NoSQL, something like that. So if you look here, there's a couple things you can do. Well, there's actually 2 phases here, right? So most likely, when you're here, you'd know what product it is. So you'd get your product ID, and then you would loop over here, and this is just JavaScript as an example, to get the product itself, to get the price history. So this call will bring back your 1,825 rows, and this returns back 1. So they're both extremely fast. You're making 2 calls. When you're doing this, what I've seen in the past is this is some kind of a microservice or some kind of a widget in here. So this thing is, everything else is not dependent on this. And this kind of loads a little bit later because it is bigger. And when you go to this scenario, you're in a polyglot database model. And you have to make sure that you care about this being up mostly, but the tertiary things or the other things may or may not be up for whatever reason. So you kind of have to design it that way. So what does it look like? In this case, the DynamoDB database structure is actually pretty simple. So you have what's considered a table in DynamoDB, and you have a partition key. In this case, we did product ID, which is ABC123, which is the ID for the wireless headphones in our use case. You have a sort key. So we sorted by price date in this case, and that just means that the object within the hash tables is sorted by that. And then you have your attributes, and you get many attributes. We just put price here. I actually stuck some other things in here as an example. You don't necessarily do that. For our use case, we would just be pulling price. In this use case, the one we just talked about, in my fictitious application, price under 2000, that tool only updates prices once a day. So this is a very good use case to just old school job, 2 a.m. After the prices get updated, you take the data, you then wing it over to, use Glue to wing it over to DynamoDB. So in this case, step 1, you trigger some job, Glue starts up, queries Postgres, product history table, or the product price history table. You transform it using probably Python, do some other fun stuff, and then you jam it into your DynamoDB table. Some extra things here, you got a dead letter queue, which is always good to have, and some CloudWatch and logs. And then finally, the structure I like, because I'm more of a I lean more towards a database person, but because I prefer those, and I think they're about 90% of the use cases. I would say in this case, you would keep about 30 days of your price history in your main database, and you shell everything else out. So that way, if there is corrections or if there's anything that you need to do locally, or if you have a small chart that says I just need 14 days, you don't have to reach out to the other system. So you have 30 days that's really nimble and small, and everything else for the big price chart is over there. So that way, it's actually in 2 spots. It's a little bit duplicated, but that's fine. You just kind of have a purge job here. And the other things you can do is you can have CDC on your database, which is change data capture. And that can, like, you'd use a product like Confluent.io or Debezium. And what those tools do is they will take data as the records change in your database here, and it'll actually post it up somewhere to a Kafka queue, and then that thing can then go to DynamoDB, which is really fun. Or the thing that updates this every night on a daily basis can do that also. So you don't have to have this as a batch job. This is just a simple use case because Product Trender 2000 only updates its prices at 1 a.m. every morning after the terrorists hit. So, all right. Before we go on, questions about DynamoDB. Who's using DynamoDB today? How many records do you have in your system? Like, just to give me a ballpark. Like, are you talking billions, trillions? What's the most anybody's ever had? A couple hundred. I've seen upwards of 10 billion in some DynamoDBs, and it's really nice, really fast, and it doesn't even flinch. So as long as you partition the table right. So that's the biggest key, is making sure that you design your data structure properly. And our second use case is type-ahead search. Has anybody used Elasticsearch yet? Cut a few people. It's a great product. I was worried when I was writing this session that I would get some flack about, well, Elasticsearch is technically not a NoSQL database. It kind of is, kind of isn't. It is in the background, but it's much more. So I didn't want to offend anybody that works on Elasticsearch and say it's just a NoSQL product. It's much more. But in this case, we're calling it NoSQL. So type-ahead search, most modern applications have this kind of thing. Some applications I've seen just query the database, and they're hammering queries for the next suggestion. You type in 3 things, it hammers the database, caches a bunch of stuff, and it's really, really expensive, especially if you have 1 million products, 2 million, 5 million products in a particular table. It's very, very expensive. So here's a scenario with or without Elasticsearch. So without Elasticsearch, you're writing queries like I like. That's a Postgres thing. It's an in-case sensitive like, or where queries within the search. There's no relevance ranking, fuzzy matching, or autocomplete. Relevance ranking uses a thing called, let's see here, BM25. It's an algorithm that says this is the most relevant thing within the. When it's looking through the indexes, it's saying this is the most relevant. Headphones is the most relevant thing based on a bunch of terms and all this really fancy, extremely complicated stuff. So it's been around for a long time, but it uses that particular algorithm in a lot of cases. Fuzzy matching is based on Lichtenstein digit distance, I think it's called. And essentially what that does is it takes a misspelled word like fuzzy, like headphones, right? If you misspelled headphones, it can still figure out oh, that's a headphone, based on some guy who's way smarter than me, wrote a cool algorithm a long, long time ago, I think in the 90s, to do fuzzy matching, and we still use it today, which is really fun. And then auto-completes. So basically the next thing. So without it, we are basically just querying the thing. It's very simple. So the pros to this is if you have a really small database and it's never going to grow, I used to call them crappy line of business applications. Some of us work on the customer-facing things, but a lot of us work on the middleware type stuff to support the business, and we have 50 users, and it never will grow beyond that. So in my opinion, if you have that scenario, this is probably fine. Just query the thing, right? Query it a bunch of times. If it's a small server, it's a small application. So this is where we get into over-architecture, and this is why the beginning, the back of the napkin math is so important, because if you don't do that, you will tend to over-architect your data solutions. And I've done it way too many times than I can count, where I've over-architected or I've under-architected, and it always leads back to me not understanding the business case behind the data, or not understanding how many records are going to be. I just didn't do the math, and it was like, I should have done it 3 years ago. And all these problems, by the way, will always be in the past, and we'll always hit ourselves, be like, I should have done that. I guess it keeps us in a job, so it's good in some ways. So now with Elasticsearch, we got autocomplete, super cool, works really good. We use SQL Server metadata. We have fast, type tolerant, and relevance ranked search. So in this case, you would actually do it would be two steps. So your web app will go fetch the results, so you'd be typing in something. It's after the third character, typically, you're hitting this thing a bunch of times. You're going, what's the next? In the fourth character, it calls again. Fifth character, it calls again. And that's how it's continuing to give back results. There are some other things, and things called debouncing, I think, to prevent overloading your Elastic cache to get the next thing. But once it does that, it will have the product ID, and it's like, cool, I got the product ID. Now I can go over to my SQL Server database and get the product back itself. So you're typically over here, and then you go over to your SQL Server database. So you're kind of separating the duties. This is kind of what the query would look like there. The Elasticsearch queries are kind of strange, in my opinion. And I do have a typo in one of these, I believe. Completion. No, this one. I have a typo in the next one. I'm sorry. I'll show you in a second. And this is what it would look like. So you have query 1, query 2. That's about it. And then you have type ahead search. This is really complex, though. There's a lot of maintenance to doing this. It's a lot of DevOps and a lot of very specialized knowledge you need. So again, I really want to stress, only use these solutions when you know that you're going to need it for larger applications, larger tables, larger things like that, because this will double your complexity of your data platform. So I'm really a big fan of doing database first and then figuring out the other things afterwards if it's needed. What does it look like? So I missed one thing, by the way. I missed the mapping thing. I'm sorry. I apologize. I beg for forgiveness. But there's 3 things to Logstash here. There's a Logstash pipeline. Or I'm sorry, I'll step back. To get data into Elastic, we typically use Logstash. You can call Elastic APIs directly, I believe, but you would use the Logstash platform, which is just basically an ETL tool, a mapper tool. It's really nice. It works well, and there's a lot of fun stuff to it, where it does the querying and everything for you. So if you look at the top of this, you have your database connection. This is something that would run, and you would set it to say run this every n period of time. So you could say run once a day or every minute. And I'm going to talk about the strategies to make sure your data is up to date in this too. So in this, we're just selecting everything. So this is more of a once a day thing, because most likely you're adding products once a day in the product 100-2000. So if you look there, there's a query up in this area. So you get a query, select a bunch of stuff from the product table. And this is basically selecting everything. And if you look here, it comes down, it's filtering. And this is where I got the, this is where I got the type wrong. So if you look there down below in filter and metadata, that should say completion, because that's the type. Because this is just an input, so this won't autocomplete. So essentially what I'm doing is I'm saying name is a new field called name suggest, and it's this type. So you'll have an index like this in your system. And it's too small for me to read. And if you notice, it's duplicated twice. You got name and name suggest. So you're basically just duplicating the data, and this should say complete. So that way when you're calling Elastic, it knows it's an autocomplete field. There's a bunch of different ones. There's one called type ahead. It's just a data type within Elastic. So you map it as you go. The one thing I'm missing is the mapping piece. So it's similar to a schema in a sense. So it's like, it's saying that for this data, in Logstash, as you get the query, the select whatever, you'll then map that to a particular schema, which is on the right here. So that's the one thing I missed in this. So just keep that in mind if you're kind of playing around with this stuff. There is another component. And again, it's very specialized. We have a few people. I've known a few people that are really good at this, but I haven't met many that are extremely good with Elastic. So just keep that in mind when you're working on this. Make sure that you have the staff to support it too. So if you go back home in your office and you say, I want to use Elasticsearch for this typehead thing, great, but make sure that your management knows that you're not going to run it, probably. And there's going to be a bunch of people that are going to be needed to run it, even for the SaaS solution. It's very complex. So I was trying to fit all this in one slide, by the way. In this case, we'll have a scheduled job, log/SaaS job, or you can do real time, which is cool too. You go to the product table. You'll do the JDBC input. And I can read that last one. Oh yeah, you'll do the transformations. And then it ends up in your log/SaaS, in your Elasticsearch. And then this is what the document looks like. I wanted to talk a little bit about on the slide about what documents look like in these systems and a lot of denormalization happens with these NoSQL products. So this is a very simple use case for Elastic, but you may end up creating a bigger index that would comprise of your client, how many products it bought, all the products they bought, and a bunch of other stuff. So that way you can almost completely get away from querying your database. As long as the data doesn't have to be 100% up-to-date relevant, this is a good solution because you're already pulling back this entire object when you do the type ahead search. So imagine your type ahead search was based on first name, last name, or just last name to find a person. You could have everything within that data object. Within the JSON itself in the index instead of reaching back to the database. That works, but what if someone came over and updated the client in the SQL Server database? You need some kind of a mechanism to make sure that you're updating the Elastic index constantly. So there are tricks and tips you can do. So in this log/SaaS pipeline, what you would do is in the settings, you would say run this often. You'd probably have another table that says, or you would have something outside in the log/SaaS thing that maintained a most recent updated date. And then you would put a predicate, oops, timed out. You would put a predicate on this query here saying where last modified date greater than this. And then you would store this update date and you would continue to kind of inch it forward. And you would just run this thing all the time. So that way your Elastic cache is really up to date all the time. It's a good strategy. It works well. And that way it's not just stale data. It depends on the use case. So just keep that in mind if you're building something like this. A lot of this stuff depends. So I wanted to go back here. I forgot about one thing. Oh yeah, so I said it before in the beginning, it was the rule of thumb. So when you're designing a system like this, the typical rule of thumb is when you're doing the back of the napkin math, you say, how many records is going to be in here? Okay, well, I project, and how do you do that, right? So you say, well, we have 1,000 customers right now. Maybe reach out to the product owner. Say, what's our growth rate, right? How many customers are we expecting? They're like, well, we're buying these two companies and we're expecting to grow 16% or whatever. So you start doing the math based off of that. And then that way you can extrapolate on, is there going to be 1 million records, 2 million records, et cetera, et cetera? And what are the entities off of that you need to build? Price history, change logs, things like that. And that's how you can kind of do that. But the general rule of thumb that I follow is about 100 million records in a table, I think is the point where you're thinking this should be outside of my SQL database and into something else. Again, it doesn't have to be Dynamo, it doesn't have to be Elastic, it just should be somewhere else most likely. And the other thing is, I got asked a few questions when I was building this. I was sharing it to my friends. I said, well, why don't you just use Snowflake or a OLAP system? The reason you want to use Snowflake or an OLAP system is Snowflake, first off, charges per query. So if you put this and you have 100,000 users and you're getting charged per query when you're querying that system. It's extremely fast. It's awesome. I love Snowflake, but you're getting charged per query. Like a SQL Server analytical server, something like that, or Redshift, things like that. Those things aren't always up. They're because a lot of them are very batch based. So you can't really, it's it's not really the best idea, in my opinion, to hook up a website that is going to be the product trender 2000 with 100,000 users and millions of products to your data warehouse, because the data warehouse is more or less for reporting and for doing the business insights for the business. So just keep that in mind when you're building stuff. It's really important. And just know you're all going to make mistakes. You're all going to misinterpret something, over-architect or under-architect, but it's safer, in my opinion, to do it, because the worst thing the worst problems I've created in my career are tables that I undersized and are just absolutely too massive right now, and we have to put so much capital into redesigning it. Because now I got to go talk to all the Scrum teams. I got to change everything on the site. I got to change all the data, because it's not as simple as just taking the data, putting it into DynamoDB, and calling it a day. There's a ton of stuff you got to do. And now you got to change all the queries to this. You're going to make all the decisions about how the stale the data is and everything like that. So, I think that's it. Yes. So that's it. I got 10 minutes left. I'm a little early, but I wanted to see if anybody had any questions or go ahead. Okay.
So if you were to make a choice between those two, how much money would you put into market adoption? Like Cassandra has about 5%, Mongo has about 35%. So would that factor in besides consistency and performance?
You know what I've done when I've decided to choose products in the past? I have gone to dice.com, monster.com, or whatever, any of the recruiting sites, and I type in that skill set and see how many people can work on it. Because one of the worst things you can deal with is Elastic, for example, is, I would say it's almost niche, right? Or the folks may be very expensive too. See how many job openings are in those things. And if you type in Java versus C#, right? Actually, I don't know if that's the same way anymore, but if you type in Mongo versus Cassandra, you'll see 25 postings for Cassandra, you'll see hundreds of postings for Mongo. That means that the market will dictate the skill set. Because the worst thing you want is a very thin resource pool for candidates. Because if that's the case, then they're very expensive, and you are so reliant on them. And it's really a miserable feeling. And there's probably a reason in some ways. Cassandra may be a better product than Mongo, but those are the things I would say. And I think as IT shifts in our careers, as we get more senior, these are the things that matter more than writing better code. Because these are the things that are going to cost the business more or less money. Because if a Cassandra developer costs $300K a year, but a Mongo's $150, and you can get Mongo developers out to free anytime, it's a better choice, in my opinion, even if it's a better technology.
That's the argument, is because even with consistency, you have eventual consistency in Cassandra, and Mongo has stronger consistency. Yeah, you have the performance, so now it's the trade-offs, and I was curious what you thought about that.
Yeah, I'm a big believer in most of the technologies are great. Like Apple iPhones are great, Samsung phones are great. Azure's great, AWS is great, GCP is great. They're all good. They all do really good things at this point, and now we're just nitpicking. So I like to take a step back and say, well, from a business perspective, what matters more? Not just a feature comparison perspective. And the business side, because we wouldn't be here if it wasn't for the business. And I think that our industry as IT professionals is switching to be more in the middle. Because we used to be, I just close the door, I'm going to write code. Now, as the industry shifts, we really have to do both sides. So we have to make better decisions about our technology versus just what's cool. Oh, yes. Oh, yes. I'll repeat the question, what I was talking about. So the question was, how would you choose between Cassandra and MongoDB? Cassandra has about 5% of market share, and Mongo has about 25%. Same goes for new products that come into the market, right? So new products might be really cool and hot, and everybody wants to use them, and everybody's jumping on the bandwagon. Sometimes those die after 2 years, and then you're kind of screwed, especially if it's a SaaS application. You can really pigeonhole yourself. So it's hard not to be a dinosaur, because we all, I want to be a dinosaur most of the time, right? But we all want to be it because it's easier. It's like, if I could just write SQL all day, I would do it. That's great. But no, I have a job to do. I have a career to run, so it sucks. Go ahead. How would I store that? It would probably be something like DynamoDB because it's so fast, the reads and writes. So if we think about it, right, I have a QSIP or a ticker, right? So let's say VU, SPY, Tesla, whatever. That data is changing throughout the day, right? And think about just the order book behind that. That's probably even deeper. You would probably have a pretty good chance to partition not just on the QSIP, but also on day, right? So I would take my partition key and do QSIP plus day maybe, or day of week, and kind of try to drill that down so it's much more specific, so that way I could seek down to the record. Because you don't want is a partition that has a trillion records under it, or a partition key within DynamoDB. So I'd probably find some kind of a better distribution of the data, right? To figure out what's the best distribution in the query patterns and understand that side. That's one thing I forgot to mention, is query patterns are so important. When you go about these things, you can't design, like databases are awesome because you can just put the schema together and everything works and you can figure it out later. DynamoDB, all these other things, you kind of have to know how you're going to query it. You have to know, oh, I'm going to query by product ID. So that way I can design the data better, right? So that's another thing. So it depends on the query pattern. So the question was, how would you design the NASDAQ ticker? And that's probably a 2-month design session. It's a very hard problem. All right, I'm going to have some questions. All right, when do you use NoSQL versus MongoDB? Who said it depends? This guy. You win this. Come down. Come down for your prize. All right. What's the rule of thumb, for my rule of thumb, for a SQL for tables?
100 million records.
Yes. Come down for your prize. Hold on, I have the other one written down. Give me a second. You're welcome. Enjoy. 3D printed those myself. Oh, what is NoSQL? Hold on, let me phrase this so don't say yet. What does NoSQL mean today? Yes, this guy. Awesome. Well, everybody, thank you so much. I feel so privileged to be able to speak at these conferences and speak in front of you. So thank you so much for all your time today. And that's it. You can contact me at LinkedIn. That's my main contact. As Jeff knows, I don't respond to it that often. I'm going to get better. But thank you all so much. I really, really appreciate it.